All right, let's move on to another topic in statistics, which is the median. And median is like the middle. It's the number for which there are as many numbers above as there are below. So it's kind of the middle number in a sequence of numbers. So to figure out the median of something, you want to rewrite your numbers from smallest to biggest. And then you're going to count from both ends to find the number in the middle. If it happens that you have an even data set, you're going to have two numbers in the middle. So in that case, you're going to add those two middle numbers together and find their mean. Okay, so let's do an example. So here we're given a data set. We have 7 numbers here. And so step 1, we're going to order them. So we order these smallest to biggest. And now you're going to count from the end in. So you could go, these are our 1s, here's our 2s, here's our 3s, and then we land on the middle number here, which is 27. So the median in this case is 27. Okay, our next data set right here has an even number of data points. So first we're going to put those smallest to biggest, which is what's been done right here. And then next we're going to count in from both sides. So we've got 1, 2, 3. So there's 2 numbers that share the middle this time. So we're going to take their average. So we add up 62 plus 73 to get 135. And then we're going to divide by 2 to figure out the average of those 2 numbers, which is 67.5. And take a look at these examples and see how that describes your data. It kind of describes it in a similar way to the mean, where the middle value tends to be a fairly typical value for your data set. And in a minute, we'll talk about the advantages and disadvantages of means and medians. Okay, so a couple examples. Let's try one together. So we want to find the median of this data set. So step 1, let's order it. And usually when I do this, I kind of cross them off as I go to make sure I don't forget anybody. Oh, and look at that, I forgot 5. Okay, then we're going to count from either way. 1, 2, oops, 3, and we end up in the middle at 8. So the median is 8. I'll just write it out here. You don't necessarily have to. The median is 8. Okay, so on this next one then, pause the video, go ahead and try that one on your own. All right, let's do this one together now. So step 1, we're going to order these numbers from smallest to biggest. We have 2 29s, so 29 is going to appear in our list twice. Okay, and then we're going to count either way. So we've got 1, 2, 3. So these 2 numbers in the middle share the middle position. So we're going to take the average of those 2 numbers. So we're going to add up 29 and 38. And that gives us 67. And we're going to divide that by 2, which gives us 33.5. So the median here is 33.5. All right, last example. Let's take a look at the homes for sale example that we did in the last section on means. So we have our home prices. Step 1, let's list them in ascending order. Maybe I won't use commas in my numbers just to make things a little clearer. Okay, next one is 249.9, 254.9, 269,000, 290,000, and then our big $2 million one. Okay, let's once again count from either end to figure out our middle number or numbers. And we have 2. So these 2 numbers share our middle position. So we're going to take their average. So let's sum them up. And when we sum them up, we get $523,900. Now we need to divide by 2 because there's 2 numbers in our small data set here of 2. And that gives us 261,950. So our mean here is about 262,000. And take a look at that compared to each of these house price values. And what you might see is that in this case, the median ends up being a better describer of our typical value than our average does. So when you have, like I was explaining in the mean section, when you have those outliers, especially when you just have one off to one side, like here we have a really, really high house price, that will really skew your mean. And the nice thing about the median is being a middle value, it doesn't kind of overweight that really high value. It doesn't kind of consider it too much. Okay. Here's another example where we're comparing mean and median. So what I'd like you to do is pause this video, calculate the mean, calculate the median hourly wage in this case, and then I'd like you to think about which salary is more typical of the average worker. Okay, and let's do this one together. So mean hourly wage. So we're going to sum these numbers. And then I'm just going to kind of shortcut it. I'm going to make this all one step. We're going to divide whatever that sum is by our number of data points, which here is 7. And if you do that, you should have ended up with 16. Okay, median hourly wage. So this time we're going to order our numbers from smallest to biggest. Make sure you put the 14 down twice because it occurs twice. Okay, and you don't have to number these per se. We could let's just actually cross them off from outers to find our middle. And here's our middle number of 14. So the median here is 14. Okay, so taking a look at those salaries. So we've got these, or not salaries, it should be wage. If we at these wages of these workers, what kind of describes the more typical worker? Well, the mean of 16, if you look at those workers, there's only 2 workers who make at least $16. So it's not really a typical value, is it? Whereas the median of 14 is more close to the typical value. So just like our house example here, that high wage of $32 really skewed our data set. So we could say the median is better because the mean is heavily influenced by the $32. That's not to say the median is always the better statistics to use. In fact, I would say the mean is used by far. It's more common in science and math and all kinds of applications. The mean tends to be the number you want, but sometimes in cases like these, it's also important to consider what the median would be. Okay, one final example comparing median to mean. So once again, calculate the mean and the median, and then describe what you think is better for describing, which statistic is better at describing the monthly phone bill here. Okay, so let's do this one together now. So first of all, we're going to find the mean. So we have a huge list of numbers here to add up. So let's add those all up. And then we're going to want to divide that sum by the number of data points, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to divide that by 12. And if you do that work, you should end up with a mean of 105.75. So that is our mean. Median, we're going to order these numbers from smallest to biggest. Okay, oof, that was a lot of work. All right, now we're going to cross off from either edge. So cross out your outermost ones, then your second, then your next ones, and so on. And what you'll find is your middle two numbers are 95. So we want the average of 95 or the mean of 95 and 95. And you might be able to do this in your head, or you can just calculate the average. The average is going to be the sum of those two numbers divided by 2, because there's 2 data points. And what do you get? 95, because the average of two numbers that are the same is always going to be that number. That's kind of like the typical value. Okay, so looking at Jessica's phone bills, we have a mean of about $106. We've got a median of 95. Which number or statistic better describes the monthly phone bill? This one is an interesting question because I think you really have to ask yourself, what are you trying to describe here? So if you're trying to describe the typical phone bill that you would expect, it might be around $95. Okay, because there's some numbers above that, there's some numbers below, but 95 is kind of in the middle of those. If you were trying to budget for your phone bill, Jessica should probably find a better phone plan. These are pretty high bills. But if you were trying to budget for a phone plan, you would probably want to use the average amount, because if you continuously budget that average amount over 1 year, you should be paying for your full phone bill every month. So we could say 95, or we'll say the median of $95. Describes a more typical bill better. And that's because Jessica had that really high bill of $242 1 month. So that really kind of skewed the mean, but the median wasn't as affected. So we'll say the mean of 105.75 is better for budgeting. We're budgeting phone expenses, let's say. And so that is mean and median.